So today we'll be doing AP Microeconomics 1.5, that's cost benefit analysis, and 1.6, that's marginal analysis and consumer choice. And with that, I will finish unit 1. All right. But before that, in my last video, there was a technical glitch because of which you couldn't see the answers for the production possibility curve 5 MCQs that I had given in last to last class. Plus, you also couldn't see my MCQs for comparative advantage and trade. And so I'll be just repeating those in this video. All right. Okay. Before we begin, so I'll just finish those and then we will begin with the new topic. All right. So these were the 5 MCQs that I had asked you in the PPC section, right? First one, which of the following would not be a part of opportunity costs of going to college? And the answer is option E, money spent on clothes. Because anyway, even if you're not going to college, you will be actually buying your clothes. So that's not the opportunity cost of going to the college, right? If you remember, opportunity cost is the cost that you sacrifice in order to achieve something else, right? Okay. Then in this graph, the graph below shows the PPC for a country producing ice cream and frozen yogurt. And that's the graph. And the question was that what statement explains why the PPC for ice cream and frozen yogurt is a straight line instead of a curve? And the answer is your option B. Sorry, it's option A, that they are interchangeable. The shape of the PPC signifies that the resources needed to produce the two goods are interchangeable. That's why it's a straight line. It's a constant slope in a PPC. Otherwise, usually the PPC is outward bound, right? So it's a concave shaped curve. Okay. I've discussed all this in my video. So if you don't remember or if you want to have a review, you can always go back to my video and have a look at it. All right, then flour is an ingredient used to make collages but is not used to make queso. Which of these graphs shows what happens when the availability of flour increases? All right, so we have collages on the y-axis and queso on the x-axis. Now this is not true because only the ingredient flour increases and that's used for making collages and not queso. All right, so basically the production of collages will increase and not queso. So the PPC curve, this one is also not the correct answer because in this queso production has increased and not the collages. This is just a movement from one point to the other. It's just that we are in fact in this we are producing less of collages and more of queso if we are moving from the upper point to the lower point, right? This option D is actually the correct one because collages, the production has increased and queso, the production has remained same because flour is not used as an ingredient in its production. Both, so the PPC curve is going inward. That's also not correct. It should go outward as in this case, right? It should move outward. Okay, only for collages. So option D is the correct answer. The fourth one says, the graph below represents a change in the production possibilities curve for the nation of Zam. Let's see. Fruit smoothies and fast cars. So I'm so sorry. So that's the curve, right? So fruit smoothies is the same production and your fast cars, the production has increased. All right. Which of the following statements about the change shown in this PPC are true? Let's see. Exim now has more resources or technology to produce more fruit smoothies. Not correct. Exim now has more resources or technology available to produce more fast cars, but not fruit smoothies. That's the correct option. All right. Option B. And the fifth one is the production possibilities curves for Jeff and Meta are shown here. So Jeff's is a concave shaped one and Meta's is a straight line. All right. What happens to each producer's opportunity cost of fresh baked bread as more bread is produced? Okay. Jeff's increases, Mita's increases, Jeff stays the same, Mita stays the same, Jeff's increases, Mita stays the same. Since Mita has a straight line PPC curve, so obviously Mita's production, the opportunity cost remains the same. And for Jeff's, it's increasing. He has to sacrifice more and more of one good in order to produce the other good. So the option is C. Jeff's increases and Mita stays the same. All right. Okay, let me move to the 5 questions that I had that I wanted to give for comparative advantage and trade, and these are the ones. All right. Which of the following statements is true about specialization and trade? These are your options. So what I'll do is I'll discuss the answers of this comparative advantage and trade, the 5 MCQs, and plus the 5 MCQs that I'll be giving on cost benefit analysis and marginal analysis on consumer choice in my next video. So in the next video, I'll be discussing 10 MCQs. All right. Okay. Second question being this. Which of the following situations would allow agents to gain from specialization and trade with one another? Using the same amount of time and resources, that's the third one. Kim can write either 10 articles or complete 5 worksheets, and Lee can either write 3 articles or complete 9 worksheets. If Kim and Leah specialize and trade, who would specialize in each good? These are your options. That's the fourth one. Joya can make an apple pie in 20 minutes and she can prepare a turkey in 60 minutes. Chris needs 25 minutes to make a pie but requires 100 minutes to prepare a turkey. Based on this information, who should focus on making turkey for Thanksgiving dinner? Fifth, this is the same one, I believe. So I'll skip this, I'll come to this. Max and Ellie like to build apps and coach soccer. The time it takes for Max and Ellie to build apps and plan soccer drills for their team is given in the table below. So they have already given you the matrix. Which person has an absolute advantage in building apps and which person has an absolute advantage in planning soccer drills? All right. Okay. I'll come back to my worksheet and now let's begin. So the first thing that we have to do is 1.5. So that's 1.5. I'll begin with this. It's called cost benefit and analysis. All right, cost benefit and analysis. That's 1.5. All right, before I begin with the analysis and with the benefits, right, let's just concentrate on this cost. Now, in economics, the cost is actually divided into two kinds of cost. One, you call it the explicit cost. Another is the implicit cost. So all the accountants, they take into consideration only the explicit cost. What exactly is the explicit cost? Explicit cost is basically the cost that tends to associate with a price. So if I say, all the tangible objects that can have a price, right? So if I say, let's say for a business, if I need a raw material, if I need labor, if I need any kind of cloth, if I need a yarn, if I need a machinery, all these costs associated, all these costs, right, are called, or they come under what we call as explicit cost. You can very easily identify them, right? You can very easily see, right, these are the costs that are involved in a business. So those are called your explicit cost. Implicit cost is nothing but what we had done in your PPC curve, production possibility curve, is another word for your opportunity costs. All right. Implicit cost is just another word for your opportunity cost. Something that the cost, something that you are forgiving, something that you are sacrificing in terms of getting something else. That's the cost. All right. Generally, what happens, accountants, they don't take into consideration this cost. But economists, they take into consideration both the explicit plus the implicit costs. Okay, we'll come to this later with an example. All right. Okay, let's go to what do we mean by cost benefit and analysis, right? So what happens, the big question is, how would a rational being, a logical person, basically make best decisions for oneself? All right, how do they do that? In economics, how do we define, or how do we see that whether a rational person is making, the best decision for oneself, right? How do we do that? How do we calculate it? Okay. Now, in doing so, what do we look at? Any person would look at, the benefits, the total benefits that person is getting, and he will also look at the total costs that person is actually incurring in getting a good or a service. All right. So let's say if I am buying let's say I am buying an umbrella. All right. So if I am buying an umbrella, what are the total benefits of actually buying an umbrella to me? Right? If I can quantify it, let's say, if I can quantify it, if I can give it a number, right? Let's say I say that the benefits that are worth is, let's say, $50 to me. All right. I'll also actually look into the total cost that this buying of umbrella, for this for buying an umbrella, I have to incur. All right. Now this total cost actually includes, let's say, if the cost of the umbrella, let's say the price of the umbrella is $30, or let's say $25. All right. Now the price of the umbrella is $25. That is, let's say, the explicit cost of the umbrella is $25. All right. So that's the explicit cost of the umbrella being $25. So yes, I'll take that cost. Plus, I'll also take the cost that if I had to, of the product that I'm sacrificing for this $25, I can actually spend this $25 somewhere else also, right? Then what is am I sacrificing, right? Let's say if that is so, if everything is quantifiable, right? So let's say that cost comes out to be $10. So I'll add that $10 into my total cost, and I'll say that my total costs for buying this umbrella is $35. So what I'll do is I'll subtract the total benefits, I'll subtract the total cost from the total benefits and see what the net result is. If the net benefit, right, if the net benefit comes out to be positive, then yes, it's basically a rational decision to go and buy the umbrella. But if the net benefit comes out to be negative, then it's not a good decision to buy the umbrella. So that's how basically, this cost benefit analysis work in economics. We basically, the underlying, thought is that we take the total benefits, we take the total costs, and then we subtract the two. And if the net benefit is coming out to be positive, then we go for that decision. If it's coming out to be negative, then we don't go for that decision. One important thing that we have to remember in economics, that in total costs we not only include the explicit cost, but we also include the implicit cost of buying a product. All right, so that's the first thing. All right, that's one that you have to see, that how optimal decision making is done. So I'll do again this with one of the examples which will clear your explicit and implicit questions actually uh, nicely. All right, okay, let me start with this. Let's say, suppose choice of going to a movie for 3 hours. So there's a choice of, let's say, so I have a choice, let's say, of going to a movie, all right, okay, 3 hours, for 3 hours, or you are working for 3 hours, all right, okay, and the movie ticket costs you, the movie ticket, the price of the ticket is, let's say, $10. Okay, and if you work, you can earn actually. So there are basically three options for working available to you. Okay, if you if you work if you work for 3 hours, right, mowing lawns. Okay, if you are mowing lawns for 3 hours, right, then what you get is $90. So this is for 3 hours, I'm telling you, right? This is for 3 hours. Okay. And if you are working in an ice cream shop, so let's say an ice cream shop, okay, then it's basically you earn $36, right? So 3 hours, right? So it's $12 per hour, all right? And let's say you are weeding, the third option being that you are weeding your aunt's house, all right? So weeding aunt's garden, not house actually, garden, all right? Now in that case, it's $10 per hour, so you are earning $30 per hour for 3 hours, all right? Now, what is the opportunity cost of going to a movie for 3 hours? How would you calculate in such a situation? Okay, so as an economist, right, as an economist, what will you take? So you will take among these three options, right? If you are going for a movie for 3 hours, basically you are sacrificing either one of the jobs, right? And if you were not going for a movie, then obviously the job that you had picked up would be this one, mowing lawns, because that is fetching you the highest amount of money. So you are actually, opportunity cost of going to the movie, opportunity cost of going to a movie is your $90, this one that you are sacrificing, plus the price of the ticket for the movie. So that's the explicit cost. This $90 becomes your implicit cost, the cost, or whatever you would be earning, that you are sacrificing actually for those 3 hours, plus the explicit cost, that is the price of the ticket. So that's your $10. So basically, what you would be having, or the opportunity cost actually for going for a movie, would be $100 for you. All right. Now, a rational being will calculate the difference between the benefits and the cost, as I told you. Now, assuming that, again, same thing, assuming that at times, or many times for that matter, the benefits are not quantifiable. right? But we do it, right? We give it a number and we say, all right, let's say that the total benefits that we actually attain or I attain by going for a movie is, let's say, $150. All right. So I'll just subtract the two and I'll say, and I'll see whether my net benefit is more or less. So it's $150 minus $100. That gives me $50. Since the net benefit comes out to be positive, so yes, it's a rational decision to actually go for a movie and not go for mowing lawns. Do you understand? Right? I hope you do. All right. Okay. Now, another concept that's very much attached to this is your accounting profit, difference between basically accounting profits. That's my short form for accounting profits. For profits, I use this symbol of pi. Difference between accounting profits and economic profits. All right. As I told you in the beginning of the video, actually, that accountants, they only take into consideration. Okay, let's start with this first. What do you understand by profit? So pi is the symbol for profit for me that I use, right? How do you calculate profit? Very simple. How do you calculate profits? Your total revenue, right? Your total revenue, that's TR. So remember these short forms, right? They are actually extensively used even in books, and I'll be using these, in my further videos as well. So TR minus your TC, total cost. Okay, so TC stands nothing else but total costs. All right. Okay, so profit generally in a very simple language is calculated, or in a very simple formula is calculated with total revenue minus your total cost. All right. If this is a positive number, then yes, your profits are positive. That means you are earning some profit. If this comes out to be a negative number, that means you are incurring losses. All right. So what's the difference between an accounting profit and economic profit? Now again, in an accounting profit, accountants, they take TR minus TC, where TC is only the explicit costs that they take into consideration. Only the explicit cost. However, an economic profit is calculated with TR minus TC, but this TC is actually a combination of your explicit plus your implicit cost. All right, that's the major difference between an accounting profit and an economic profit. Okay. So, what can happen at times is that you have a positive accounting profit, but you might have a negative economic profit. That might also happen. All right. So, let's do an example for this so that you understand that better. All right. Let's say Sally runs a business that only sells hamburgers. All right. So Sally runs a business, right? So she runs a business of hamburgers. Okay. And she runs it in a building that she owns. All right. So she runs the business of hamburgers and she owns the building right, in which she runs the business. All right. Okay. Every month, they sell 5,000 hamburgers at $5 per hamburger. So basically, the sale is the total revenue being 5,000 hamburgers into $5 per hamburger. That turns out to be 25,000. Correct? All right, that's the total revenue for her. Okay, now she spends, so let's calculate the total cost for her. Okay, she spends where am I? Okay, she spends $2 per hamburger on supplies. All right. So $2 per hamburger on supplies. So let me put it this way. Supplies basically means bread, meat, lettuce, whatever she puts in a hamburger, right? So supplies, and that's $2 per hamburger. Okay, so that turns out to be 5,000 hamburgers she's making, and that's $2 per hamburger. So my total cost comes out to be 10,000. Okay, then she also pays Mike and Raj each $2,500 per month to work at the restaurant. All right. So she pays Mike, basically labor, right? She pays $25 per month. So that comes out to be $25 per month. And Raj also. So it's $25 per month. And so this is all per month expenses and per month revenue that we are calculating, right? Okay, so these two turn out to be the labor for her. All right. Okay, that's the labor cost. And then she has some utility cost, which is $500 per month. So then she has the utility cost, that's $500 per month. Okay, that's about it, right? And then it says that Sally works full time and keeps the accounting profits for herself. What is the accounting profit of the business? So let's calculate the accounting profit. So given this, first let's calculate, that's your TR, that's your total revenue. Let's calculate the total cost. If you'll calculate, that comes out to be 15,500. All right. So now her accounting profit will be given by, so you just subtract her accounting profit. Her accounting profit will be given by $25,000 minus $15,500, and that turns out to be $9,500. So yes, she is earning pretty good economic profit per month. All right. Now let's say this all is true as long as there is no implicit cost, right? All right. But let's say that there are some implicit costs, and let's see what are those implicit costs. Okay. Sally could rent out her building for 5,000 per month. So now let's just calculate the implicit costs. Okay. First, rent on building that she could have earned where she is operating her business, right? Because she is using her own building for actually doing her business. But if she rented out her building, then she could have earned actually rupees 5,000 per month. All right. And she can also make rupees 6,000 per month as an accountant. So by profession, she herself is an accountant, and she could have earned $6,000 per month if she goes out to work. All right, which makes it 11,000 in total. These are the two implicit costs that she has. All right. Now, for taking into consideration the economic profit, I will subtract the explicit cost as well as the implicit cost from the total revenue. So total revenue was $25,000, from which I'll subtract your $15,500, and I'll also subtract $11,000. All right. Now this gives me a negative of $1,500. So economically, it's not viable for her to continue the business because the economic profit is coming out to be a negative number. All right. I just wanted to show you that you could also have a negative economic profit in spite of having a positive accounting profit. All right. So that's why, economists, they actually take into consideration this economic profit and not just the accounting profit, because implicit cost is an important cost for economics, the cost that we are sacrificing for doing a particular thing. Okay. All right. So with this, I'll start with the next topic, that's marginal analysis and consumer choice. So let's first understand what is marginal analysis. All right, that's basically 1.6. Marginal analysis and consumer choice. Okay. So, what do we mean by marginal analysis? And let me tell you, in microeconomics, understanding the concept of marginal analysis is very, very important. It's a kind of a building block for AP microeconomics, or for microeconomics as such, right? You really have to understand the concept of marginal, right? Okay, so what do you understand by marginal analysis? Basically, in marginal analysis, what do we do? Economists, what do they do? In marginal analysis, it basically involves comparing the additional benefit of increasing a given activity with the additional cost. All right. So before this, we did that what are the total benefits and what are the total cost, and we take the difference between the two in order to see whether the net benefit is positive or negative, right? But when we come to the marginal, we only take into consideration the additional benefit, one more benefit that we are getting by, let's say, increasing my one more unit of consumption of a good, right? With the additional cost that I am incurring by consuming that additional quantity of a good or service. That's what marginal is. Marginal is always about one more additional benefit and one more additional cost, right? So we basically, again, the same logic. So we take the additional benefit. Now one more additional benefit is termed as nothing but your marginal benefit, right? So instead of total benefit, we come to the marginal benefit. One more additional cost that we incur by consuming one more additional unit of a commodity or a service, we call this additional one more additional cost as marginal cost. So basically, we compare the marginal benefit and we compare the marginal cost. And in doing so, right, when this is done, when we compare marginal benefit and marginal cost, so basically we are comparing marginal benefit and marginal cost. It helps individuals or also the firms in deciding whether to increase, decrease, or maintain their consumption and production levels. All right. So by comparing the marginal benefit and marginal cost, basically it helps the individuals and firms to increase, decrease, or maintain their consumption and production levels. And that's what we'll be doing further down in this course, right? Today in this video, I will be doing about the consumption thing, right? About the consumption levels, that how does this marginal analysis of marginal benefit and marginal cost helps the individuals to increase, decrease, or maintain their consumption levels. And the production will be doing in the in further down in different unit. All right. Okay, now with this, let's understand what. So, coming to this, that how do we actually see that, or how do we understand that, marginal benefit and marginal analysis, marginal cost, it helps to increase, decrease, or maintain consumption levels. What you really have to first understand is one term which we call as utility. Okay, what do you understand by utility? Simple language. What do you understand by utility? Utility is nothing but, let's say, usefulness. It's any worth of something, right? Happiness that you get. It could be a value that you give to something that you consume or use. Or you can also say utility being in terms of your satisfaction that you get by consuming a product or a service, or maybe the benefit that you get by consuming a product or a service. All right. That's what utility is, right? So, utility could be anything of these, right? It could be the happiness that you get, the satisfaction that you get, the benefit that you get, the worth of it that you get of a product or a service, the value of the product or a service that you get. All anything of this is your utility, right? By consuming a product or a service. That's what utility is all about. Now, economists, there's a way that economists they try to measure this utility with utility units. So this utility has been given units, right? And that unit is called utils. All right. That unit is called utils. So economists, they actually give, they try to measure this utility with some units, and they call this unit as utils. This kind of utility where we say that it's measurable, right? Where a set of economists or a group of economists, they think it's measurable and they have given this unit called utils, comes under what we call as cardinal utility. All right. Okay, we don't have to go much into the depth of this in your AP micro course. So that's why I'm not going in much into the depth. But yes, that's what you have to understand with utility. Now, with this utility, what we come to, and that's what more important is, what we come to are two terms now that your utility is related to. One is your total utility. That is, in very simple language, the total satisfaction that you get, okay, by consuming the units of a product, right, or a good or a service, anything. So the total satisfaction that you get by consuming, the units of the product, okay. It could be the product, could be a good or a service, anything. And another one is your marginal utility. Now, again, the marginal utility is basically your additional utility. Additional utility one gets by consuming an additional by consuming an additional unit of a good or a service. All right. That's the major difference between total utility and marginal utility. So, total utility is basically the total satisfaction that you get by consuming the number of units that you have consumed. Marginal utility is basically the additional utility that you get by consuming an additional unit of a good or a service. All right. Now, since that's the case, so marginal utility, going forward, I'll be using these symbols for total and marginal utility, TU and MU. So, with this, what we come to the conclusion is that marginal utility is nothing but the change in total utility, right, divided by your change in units that you are consuming. So, this comes out to be nothing but the slope of total utility, right? So marginal as such is nothing but the slope of the total function that we are referring to, right? In this case, we have started with utility. So our total function out here the function that we are actually considering is the utility function. So the total utility, that's the total function. So marginal utility is nothing but the slope of total utility. And slope, we all know that it's, usually how do we calculate a slope? We calculate a slope by change in y by change in x, right? So here we'll just plot it, right? The total utility is nothing but your y, and your units consumed is nothing but your x. So it's the change in total utility divided by your change in quantity units of a good that you are consuming gives you your marginal utility. All right. So remember this, that's very, very important, that it's given by this formula and it's nothing but the slope of total utility curve. All right. I'll give you a table so that you understand that better. Let's say I have to consume number of ice cream scoops. All right. And here I have the total utility that I derive by consuming the product or the number of units of ice cream scoops. And then I have marginal utility. Okay. All right. So 1, 2, 3, 4, 5, 6, and 7. All right. So when I consume one ice cream scoop, my total utility is 100. Now, remember, this is given the fact that we can actually measure utility, right? In the beginning, I told you that the utility that here we are talking of is measurable, and the units given to this is utils. Right. So if I'm consuming one scoop of ice cream, I'm assuming that, all right, I can give a number to my satisfaction or to my utility that I have achieved. And that number is, let's say, 100 utils. All right. Then with 2, it goes to 180, and then it goes to 240, and then it goes to 380. Sorry, then it goes to 280. Then it goes to 280, and then it goes to 300, and then it remains at 300 actually then, and then it comes down to 280 again. So now if I have given you this table, how will you calculate marginal utilities? As I told you, marginal utility is nothing but change in total utility divided by change in Q. Q out here is nothing but your ice cream scoops, the product that you are consuming. And marginal utility is this. All right. So at 1, my total utility is 100, my marginal utility remains same because that's what I got, right? The same thing. But since there cannot be any change, right? But going from second unit of consumption, the change in my total utility is what? 180 is 180 minus 100. That's my change in total utility. Divided by change in Q, which is nothing but 2 minus 1. So 2 minus 1. Now this gives me my marginal utility as 80. 180 minus 100 is 80. 2 minus 1 is 1. 80 divided by 1 is 80. All right. Similarly, you calculate for unit 3. So now in this case, it would be 240. Always remember it's the change. So it's the change from the previous one. So it's 240 minus 180 divided by, that's the change in total utility you have got for the third unit, divided by 3 minus 2, since you are increasing ice cream scoops only one at a time, right? So 3 minus 2, so 3 minus 2, which is again 1, and you get 60 being your marginal utility for the third unit. This 80 is for the second unit. For the first unit is 100. For the third unit is 60. And similar way you have to calculate it until your unit 7. So when you calculate for fourth, you will see that it comes down to 40. For the fifth one, it comes to 20. For the sixth one, it comes to 0 because 300 minus 300 is what you get. And for the seventh one, it comes to minus 20. All right. So do you see that? That your total utility might be increasing, but your marginal utility right from the second unit has started falling. This is what actually happens when we consume commodities. All right. So our additional utility, marginal utility is nothing but the additional utility. So it's the additional utility that we derive by consuming one more unit of a commodity. That additional utility keeps on declining right from the second unit of the product consumption. That's what this is. And this is what your law of diminishing marginal utility also says. This is what actually law of diminishing marginal utility is. So it says that ceteris paribus means ceteris paribus, right? You will come across this term many times. Ceteris paribus means other things remaining constant. Other things remaining constant. So I'm keeping all the other things constant in the world, right? I'm keeping everything else constant. What I'm assuming is two or three things. First, the consumer is a rational consumer, right? The consumer is continuously consuming this product. There are no breaks in the consumption, right? And he is in full consciousness. He is not drunk and he's not being forced or anything like that. So, and there are several other assumptions. Under those assumptions and keeping other things constant, if we keep on consuming product, then the marginal utility that we derive from the consumption of the product keeps on declining right from the second unit. Right? That's what the law says. It's an important law. And actually, you can experience this law in your everyday life. Right? It's called law of diminishing marginal utility. Okay. Now, given this table, if you plot this, right, I'll recommend you to plot it yourself. If you'll plot this, you will see, if you'll plot these numbers, right, you will see that the graph will be something like this. So I have total utility and marginal utility on my y-axis, and I have this ice cream scoops on my x-axis, right? So I have 1, 2, 3, 4, 5, 6, and 7, right? 1, 2, 3, 4, 5, 6, and 7. All right. And here, if I plot the numbers for total and marginal utility, so I'll take a gap of, let's say, 40. Okay. So I have 40, I have 80, I have 120, I have 160, then 200, then 240, then 280, and 320. Okay. 40, 80, 120, 160, 200, 240, 280, and then 320. Given this, and also I have a negative number of minus, let's say, 20. All right. Now, if I plot the table that I have given you, if you plot this, you will see that for the first one, it was about 100 somewhere here, right? So if I plot it from here, if I start from here, right, you will see that the graph will look something like this. Okay, it's highest at what point? Let me see if I'm making it right. So at the fifth unit, the graph is actually at the peak. Okay, so let me just, you will see that the graph will be something like this. So at the fifth, it's at the peak. It's not a very straight line, but bear with me for this. It's at the peak and then it starts declining. All right, that's your TU graph, total utility graph. And you will see that your MU graph will be something like this. So at the sixth unit, the MU graph is 0, and then it's going down at the 7th at minus 20. All right, that would be your MU graph. Okay, fifth and sixth both are the peaks, so it's 300, 300. So basically, at the sixth unit as well, you will have a peak. You will be there only. Hang on, let me actually draw it that way. So it attains the peak at 300, and then it's actually a little flatter until 6, and then it starts declining. All right. Now always remember, it's a simple math that a function whenever is at the peak, then I mean, at the highest value or at the lowest value, then the slope of that function is equal to 0. So that is why when mu is at max, right, will be at max when your total utility will be at max when your marginal utility is at 0. So what we have is basically, certain relationships between TU and MU. All right, so let's just see that. First, total utility is increasing at a decreasing rate, which basically means that mu is falling. I'll go back to the table so that you understand. So total utility is increasing. So from 100, 180, 240, 280, 300. So total utility is increasing, but at a decreasing rate. Mu is nothing but the rate at which total utility is changing. So the rate is decreasing, 100 to 80 to 60 to 40 to 20. That's what it shows, to 0, right? So total utility is increasing at a decreasing rate, meaning mu is falling. So I'll write that down. This is basically the relationship between your total utility and marginal utility. Total utility increases at an decreasing rate when marginal utility is falling, right? Second is this one. TU is maximum when marginal utility is 0. All right. And the third one, TU decreases when marginal utility is negative. All right. So basically, so I'll show this on the table as well. So TU starts declining from here 300 to 300 to 280, and your marginal utility turns negative. That's what this, the relationship between total utility and marginal utility is. Graphically, that's how you have to show, and you have to understand this. And in terms of words, that's what you have to understand. So it's increasing at a decreasing rate, which basically means mu is falling. When it's maximum, then mu has to be 0. And when it decreases, then mu is negative. So, giving it a practical angle, basically you stop consuming a good when your marginal utility reaches 0. Right? For some, you might stop when your marginal utility starts declining, right? It starts declining. You might, in this particular case, one might stop at, unit 3, one might stop at unit 4 when it sees that its marginal utility keeps on declining. But at when the marginal utility starts turning negative, then, generally all the individuals, they just stop consuming that good. If you are having any kind of dissatisfaction by consuming that good, you will not consume that good. And that's what the negative marginal utility basically represents, a kind of a dissatisfaction, right? That you are not having any usefulness by consuming that good. You're not having any satisfaction by consuming that good. So you will stop consuming that food or, that product, good or a service. Okay. For different people, the stopping point could be different. It all depends from person to person. So that's why, in economics, we really cannot say that this is a point where one stops. No, it differs from person to person depending upon, their behavior, their interest, the likeliness towards a good or a service. It all depends upon, person to person. All right. Okay. Now, the last thing that we have to do is basically, how does an individual maximizes the utility? Okay, so we have understood that an individual will stop consuming a good when, the marginal utility turns out to be negative. And we also have understood that as we consume more and more of a good, then the marginal utility starts declining for us for that good. All right. But then where do we stop, right? Basic question. So then, again, as I told you that it differs from person to person. So then how do we actually calculate that? Where is that utility maximization for each person, right? How do we calculate that? All right. And this is what brings us to what we call as, your consumer choice theory. Okay. Now, the main assumption that we take into this, so basically what we have is utility maximization. Now, in this, the main assumption that we take is that consumers, they face constraints. Consumers face constraints We all have constraints, right? We have budget constraints, we have time constraints, we have n number of constraints, and they have to make and they have to make optimal decisions accounting for those constraints. Right, and they have to make optimal decisions accounting for these constraints. Whatever constraints the consumers face, they have to make optimal decisions accounting for these constraints. So that's the main assumption that we take into this. All right. So what does it say? It says that, for a single good, if I'm talking of a single good, then the utility would be maximized where my marginal utility for the consumption of X good, whatever good or service I'm consuming, is equal to the price of that good. Okay, we obviously, I have to bring in price, right? Because it's a cost for us. And again, so as in the beginning, the marginal analysis thing I told you, so we compare basically the marginal benefit and the marginal cost. So marginal utility and marginal benefit, they are not two different things. It's the same, right? As I explained you, utility is nothing but the benefit that you get. So marginal utility or marginal benefit, both means the same, right? Okay. All right. So, and yes, price of a good, whatever we are consuming, is nothing but a marginal cost to me, right? If I'm consuming one good, then price of that good is a marginal cost to me. It's the additional cost to me, right? So as long as I get this equation, the marginal utility of my good is equal to my price of that good, then for a single good I'm talking of, then it means that I have attained utility maximization. All right. Now, but in real world, it's not just one good that we consume. All right. We have several goods to consume. So then how do we actually calculate it? So to maximize our utility, what one should get, right, is basically the marginal utility from good 1, the per dollar actually marginal utility from good X should be equal to the marginal utility you derive per dollar from good Y, should be equal to the marginal utility that you derive from consuming good X per dollar actually, and this goes on for n number of goods that you have, and this should be equal to a constant. That's marginal utility of money, right? So in simple terms, what does this mean? This basically means that to maximize utility, consumers, they allocate their spending between products. One should allocate its spendings between products so that equal marginal utility is derived from the last unit of money or the last unit of dollar spent on each good. So basically, if I just reframe this basically means that if I have one last dollar left, right? Then if this is the situation I get, if I'm already at this situation, if I have one last dollar left, right? Then basically, if I am indifferent whether I should buy good X or good Y or good Z or good n minus 1 or good n, then I say that I have maximized my utility. This in turn means that the per dollar, right, marginal utility that I have derived by consuming good X is equal to the per dollar marginal utility that I have derived by consuming good Y is equal to the per dollar marginal utility that I have derived by consuming good X, and that's true, and if that is equal for all the n number of goods that I have consumed, then I have maximized my utility. That's what it means. This is what we call as law of equi-marginal utility. All right. So if I say that, if I say this basically means, now I'll just confine it to two goods just to make it simple, right? So this basically means my utility would be maximized when I meet this condition. mu of x divided by p of x should be equal to mu of y by p of y, where mu of x is nothing but the marginal utility derived from unit x. P of x is nothing but the price of that x good. MUY is nothing but marginal utility derived from consuming good Y, and P of Y is nothing but the price of good Y. Or I could just rewrite this as MUX divided by MUY should be equal to my price ratio, P of X by P of Y, right? And if my P of X is equal to P of Y, so if the prices of two goods are equal, then basically my marginal utility derived from two goods would be equal, right? Now let's see what happens if one has a higher utility per dollar as compared to the other. So what if I have, if the marginal utility derived from good X per dollar, right, is higher as compared to marginal utility derived from good Y per dollar, then what will happen? Since I am deriving more marginal utility by consuming good X, so what I'll do is I'll consume more of X given my budget, right? Given my budget, which is fixed, more of X is consumed and less of Y. A very interesting thing happens when this happens, right? When more of X is consumed and less of Y is consumed. So let me give you this a number. Let's say this mu of X and P of divided by P of X is right now, let's say this is 9. Hang on. Okay, let's say this is 9. And let's say this is 7. Okay. So what happens when I start consuming more of X, since I have a higher utility, marginal utility per dollar from good X, so obviously I'll consume more of good X. So I start consuming more of good X and less of good Y, or maybe I just keep my Y constant, right? Consumption of Y constant. But what will happen when I consume more of X? Then if you remember, according to the law of diminishing marginal utility, my marginal utility of X starts declining. And it starts declining. It comes to maybe 8.75, then 8.5, then 8, and then 7.5, and then to 7. So I'll stop as soon as I get this mu of x by p of x equals to mu of y by p of y. As soon as this ratio comes to 7, I will stop, because that would equate my marginal utility per dollar from both the goods, and that would maximize my utility. So you understand this? So yes, if your marginal utility per dollar from a good is higher, you will consume more of that good. But as you consume more of that good, according to the law of diminishing marginal utility, this marginal utility starts declining. So you go from 9 to 8 and to 7, and maybe then you stop. The moment both of these ratios are equal, you attain maximum utility. Now, just the opposite will happen if I have given you marginal utility of x by P of x is less than marginal utility of y by P of y. Now, in this case, you will consume more of y is consumed and less of x. So either you can, let's say if again, if let's say this is 10 and let's say this is 7. So either you can consume more of y, that will bring down the marginal utility of y to a lesser number, or you start consuming less of x, that will actually increase your marginal utility from x from 7 to 8 to 9. Either way, you work out either way. The point is that these two ratios should be equal to have maximum utility for a consumer according to economic theory. All right, I hope you understand this. It's very, very important. I'll in my next video, which will be very soon, I'll actually do a very detailed question on this particular concept. And it's kind of an your free response question, you might say that. It's a very detailed one so that you understand this concept much, much better. All right, this finishes unit 1 in AP Microeconomics. All right, I'll just give you some FAQs for this particular section. 5 FAQs actually. And in the meanwhile, I also want to say that if any of you want to enroll for AP Micro and AP Macro, then please contact me. My number is 9818787071. You can also look in to my YouTube channel, and on my website you will find there. All right. Okay. And let me give you questions on cost benefit analysis. All right. That's the first one. Which of the following best describes an optimal choice? That's the second one. Fan is deciding whether or not to invest in a project. This project cannot be broken down into increments, and she has the choice of either investing in it or not. What is true about Fan's decision? Okay. Two of this, and I would also like to give you three of the marginal analysis one. So the table below shows the utility Anna gets from drinking cups of coffee in a day. So I've given you the table. Which of the following best describes the pattern exhibited by Anna's utility from drinking coffee? The table below shows Karina's marginal utility she experiences when she visits Wild Waves Water Park. How many visits provides Karina the highest total utility? And this is the last one. Enzo is deciding whether to buy a gym membership or to pay each time he visits the gym. The table below shows Enzo's expected total utility from visiting the gym in a month. Assume Enzo decides to purchase an unlimited gym membership that allows him to go as often as he wishes after he has paid his monthly membership fee. What is the maximum number of times Enzo will go to the gym? All right. So with this, I'll stop. Hope to see you next time. And next time, as I told you, I'll be doing a detailed question on the utility maximization problem. All right. See you until then. Bye bye. Have a good day.